Okay, for our first example, we're going to do factoring a polynomial with complex zeros. I'd like you to go ahead and find the zeros, the rational zeros of this function. You can do this using the rational zeros theorem, or you can go ahead and do this using your graphing calculator. If you're going to use the rational zero theorem, you're going to use the factors of 19 over the factors of 9. Not pretty factors, but they can be done. If you go into your window, we're going to start around 0. And then for this one, it looks like 1/9 is going to be our smallest interval that we need to focus on. Go ahead and look at our table of values. And we're looking for 0 in the y. So once I find 0 in the y, boom, there's my first guy. So my first 0 is at x equals -1. The idea with synthetic division is once I know a 0, I can go ahead and find my other zeros. Now what you saw with this picture is the idea that we have a graph, and there it is. That's the good viewing window that I gave you. The good viewing window is hanging out right here. So that's your x's and this is your y's. But when I'm looking at this, you can tell that this has the shape of a cubic function, which we have an overall degree of 3. Positive leading coefficient, but you're only seeing 1 0. What that is telling you is that your other two zeros, because remember what we learned yesterday is we look at the degree, and that degree tells me the number of real and the number of complex zeros. So if I look at that sketch, what this is telling me is I have one real 0. That means my other two remaining zeros are going to be imaginary or complex numbers. So we're going to factor out that known 0, which is -1. So 9, -3, 7, and 19. No placeholders are needed. And then we have a quadratic. So remember, this is my remainder. We need a remainder of 0 to prove that that is an actual factor. So we have 9x squared minus 12x plus 19. I always am, when I'm working through this type of problem, as in I'm trying to find zeros, I typically am going to use the quadratic formula. Really up to you what you decide to use. Okay, so quadratic formula, you're going to get 12 plus or minus radical negative 540 over 18. I factored, or I should say I did the factorization rather, of 540. So remember we pull out pairs. I pulled out a pair of 2's, a pair of 3's. What I was left with was 3 and 5, which is why I have 15 in the numerator. 2 times 3 gives me 6. The negative turns into I. 12, 6, and 18 all have a common factor of 6, so I took 6 out of each of those. 12 divided by 6 is 2. 6 divided by 6 is 1. 18 divided by 6 is 3. So this is my resulting answer for my two other x values. So these are going to be considered roots. They're going to be considered zeros. When we get them in the right form, they would be linear factors. They are not, however, x-intercepts. I would suggest that you confirm your zeros when you get your kind of ugly looking zeros. And by confirm, I mean you're going to throw it into your graphing calculator and make sure when you evaluate your original function, your original polynomial rather, that you get 0. That's what we're kind of looking for. So when I put it into my calculator, I did 2 over 3. I just split this guy into his two little pieces, plus 15, radical 15 thirds. Now I would suggest doing that that part kind of in its own set of parentheses, just so your calculator doesn't get too confused. I could have put the I in front. I just chose to put it in the back either way. Stowed in x, you're going to recall y1. And this is 2.1 with, sorry, this is a hard one to read. What this is saying is there's really no real part. And it's saying this is 2.1 with 12 zeros after your decimal I. So essentially it's 0 plus 0i, which is giving you 0. So this is our nice correct answer. Your job was to get this guy into his factored form. So it says factoring as part of our example. In order to factor, you do need to know all of your imaginary parts and all of your real parts in the sense of your zeros. So my first zero is at -1. My next zero is at 2/3 plus I radical 15 over 3, and x equals 2/3 minus I radical 15 over 3. Now this one's going to be easy to get into its linear factor, x plus 1. This guy, probably not. I would go ahead and multiply each side by 3, so I get 3x equals 2 plus I radical 15, and then just move all the parts over so your right hand side is equal to 0. So take away 2 from each side, and then take away I radical 15. Same with this one, multiply everything by 3, and you're going to take away 2 and add that imaginary part. So the factored form, x plus 1, 3x minus 2, minus I radical 15, 3x minus 2, plus I radical 15.